Situation 5. For given semi-log graph, write y in terms of x. We will take e as base both sides. Because we do know a to the power of log base a of x equals x. E to the power of natural log of x equals x. 10 to the power of common log of x equals x. We will take e as a base on both sides. We do know a to the power of x times a to the power of y equals a to the power of x plus y. We will do backwards. So we get e to the power of mx times e to the power of b. We also know a to the power of x to the power of y equals a to the power of x times y. Let's do the backwards. For this, we got e to the power of m, then to the power of x times e to the power of b. Let's rewrite y equals e to the power of b times e to the power of m, then to the power of x. You could say this is an exponential relationship between y and x. So semi-log graph will result in exponential modeling. Situation 6. We also given this semi-log graph. Write y in terms of x. We are given common log instead of natural log. We use the same method as the situation 5. We got y equals 10 to the power of b times 10 to the power of m to the power of x. The relationship between y and x is exponential. So remember, semi-log graph results in exponential modeling. Let's talk about this slope m in semi-log graph. When m greater than 0, you could say the relationship between y and x is exponential growth. When m less than 0, the relationship between y and x is exponential decay. Let's go to situation 7. For given log-log graph, write y in terms of x. We will add 10 as a base on both sides. So we got y equals, for this m common log of x, we will use this formula backwards to get common log of x to the power of m. Then 10 to the power of common log of x to the power of m equals x to the power of m. Because a to the power of log base a of x equals x. So we get x to the power of m times 10 to the power of b. Organize 10 to the power of b times x to the power of m. This is y. You could say this is the power function model. Let's go to situation 8. Using the same method we did in situation 7, we got y equals e to the power of b times x to the power of m. The relationship between y and x is a power model. You could say this m is an exponent in this power model, but in this log-log graph, this m is a slope. When this m is positive, the relationship between y and x to the m's power is directly proportional. When m less than 0, the relationship between y and x to the m's power is inversely proportional. We will use this policy to remember semi-log results in exponential function model. Log-log results in power function model. Log-log graph results in a power function model. M is slope in this log-log graph. N is the exponent in this power function model. When m greater than 0, the relationship between x to the power of m and y is directly proportional. When m is negative, the relationship between x to the m's power and y is inversely proportional. Let's talk about a semi-log graph now. A semi-log graph results in an exponential function model. M is slope in this semi-log graph, and it's an exponent in exponential function model. If m greater than 0, the relationship between x and y is exponential growth. If slope is negative, the relationship between x and y is exponential decay.